This is Algebra 2, Unit 11, Lesson 3, the rest of the notes on the unit circle. Okay, so we have the last quadrant to do for the unit circle. So let's just review the three basic angles that we have, the 30, the 45, and the 60, because we need those for the other quadrant. All right, so just to remind us, when we have the 30-degree angle, that would be the angle here as the unit circle. We know the radius is going to be 1. And if this is 30, then that means that this side over here is going to be 1/2 because it's across from that. And this side is going to be the square root of 3 over 2, making this coordinate, the x value is the square root of 3 over 2. The y value is 1/2. So that's going to be at 30 degrees. Okay, at 60 degrees, or 45 degrees, excuse me. 45 degrees is this pink one. All right, remember this is an isosceles right triangle whose sides are both the square root of 2 over 2. So this is the square root of 2 over 2, and this is also the square root of 2 over 2. So my coordinate point is going to be over square root of 2 over 2 and up the square root of 2 over 2. All right, and then our third angle would be the 60-degree angle. We do that in blue, so we're consistent. There's the 60-degree angle. Okay, so that's going to be very similar. This one's the 30, this one's the 45. So this one is going to be the 60. So that means that this side is going to be the square root of 3 over 2, and this side is going to be 1/2. So that makes the coordinate point 1/2 the square root of 3 over 2. Okay, so why am I going over these three? Is because they apply to all the different quadrants. It's going to be all three of these angles just in a different quadrant. So what all that's going to change is going to be the sign. So now that we know that, let's take a look at the fourth quadrant. All right, if I flip down here to the fourth quadrant, okay, let's start with 300 degrees. Okay, so 300 degrees goes around from 0 to here. That's to 300 degrees. That's the terminal side. So what is the reference angle going from the x-axis to 300? How many degrees are left? Well, from here to here would be 60 degrees. So that would mean that we're going to use the reference angle of 60 degrees, which is the blue one right here. It's going to look like, where's my blue? It's going to look like this. All right, because 60 degrees would be there. So that means that this side over here would be the square root of 3 over 2, and this side over here would be 1/2. But we're in the fourth quadrant. What do we know about the coordinates in the fourth quadrant? Well, the x-coordinate would be positive, but the y-coordinate would be negative, right? So this would actually be, oops, that's not 1/2. This one's 1/2, sorry. Wrote the wrong place. This one's the 1/2. All right, so this one would be 1/2, but this one would be negative square root of 3 over 2. All right, so the coordinate at 300 would be 1/2 negative square root of 3 over 2. Okay, all right, so that's the 300. All right, now 315. We go around and end up here terminally, because the terminal side of the angle is here. How many, if this is 315 and this is 360, how many degrees away is this? Well, the reference angle for this one is going to be 45. So we want to use the yellow triangle. We're going to take, or the pink triangle, excuse me, the 45 one. All right, so again, when I draw the pink triangle in for 45 degrees, there's the terminal side. Whoops. All right, and I draw my triangle out to here. Oops. And that means that if this is 45, these two sides are going to be the square root of 2 over 2. And then the hypotenuse is going to be 1. So that means in this quadrant, the x is positive, the y is negative. So this is going to be the square root of 2 over 2, negative square root of 2 over 2. All right, and that leaves 330 degrees. What's the reference angle for 330 degrees? Well, if going around this way is 330, that leaves 30 degrees left between here and here. So that's the terminal side. Let me do my yellow. So I'm going to use the 30-degree angle. Whoops. pretend I can draw straight lines. All right, so if this is the 30, that's my reference angle. All right, again, this is going to be 1/2. This is going to be square root of 3 over 2. All right, now, since this is in the third quadrant, the x is positive, the y is negative, so this is actually negative 1/2. All right, so 330 degrees is actually going to be over square root of 3 over 2, square root of 3 over 2, and then down negative 1/2. All right, so there are your unit circles. So just by knowing 30, 45, and 60 and flipping them into the different quadrants, you can see where the reference angles gives you the values very easily. Okay, so let's see if we can figure out some values based on those angles. For each of the following angles drawn in standard position, give the coordinate pair from the unit circle. All right, so negative 120 degrees. Let's draw that for a second. I'll do a quick drawing. Negative 120 means instead of going counterclockwise, you go clockwise, and that would be over here, negative 120. So what reference angle would you have for negative 120? Well, wouldn't that be 60? Yeah, that would be the 60-degree angle. All right, now if this is the 60-degree angle, it's going to be coterminal with a 240-degree angle, right? So we are in the third quadrant. What do we notice about the coordinates in the third quadrant? They're both going to be negative, right? So it's got to be negative and negative. So we have to use the 60 in the third quadrant. All right, let me go flip back here. Here's 60 is 1/2 square root of 3 over 2, but it's going to be in the third quadrant down here. All right, so it's actually going to be negative 1/2. Whoops. Sorry. Negative 1/2, and then negative square root of 3 over 2. So we know that. All right. 495 degrees. All right, well, let's see. Around once is 360, and then we have to go how much farther to go to 495? Well, let's see. If I take 495 and subtract 360, I end up with 135. So I end up over here in the second quadrant at 135. All right, so what is my reference angle going to be to 135? Well, it's actually going to be 45. All right, so we have to know 45, but we're in the second quadrant. What do you know about the coordinates in the second quadrant? Well, in the second quadrant, the x is positive and the y is negative. So the x is positive, the y is, the x is positive. Sorry, wrong one. The x is positive, the y is negative. And since this is a 45-degree angle, we're going to use the values for 45, which are the square root of 2 over 2, square root of 2 over 2, but just in this quadrant over here, it's going to be 135. All right, so it's square root of 2 over 2, and then the negative square root of 2 over 2. So there's the 45. So once you figure out what the reference angle is, you're all set. Okay, now this also works for radian measure as well. You just have to know what the angle measure is. If we have pi over 3, what is that in degrees? Well, remember to figure out change from radians to degrees, you multiply by 180 over pi. All right, if you multiply by 180 over pi, that's going to give you, pi cancels, this is going to give you 60 degrees. Okay, so if this is 60 degrees, we want to look at our reference angle for 60 degrees, which is back here. Whoops. 60 degrees is 1/2 and the square root of 3 over 2. There's your coordinates. Okay, and then letter D, 3 pi over 2. All right, again, we're going to change this into degrees, multiply by 180 over pi. All right, the pi's cancel, 2 cancels into 180, leaving 90, and then 3 times 90 is 270 degrees. All right, now 270 degrees is a quadrantal angle. All right, so it's on the quadrant, on the one of the quadrant lines. So if we go back here, this is 270 degrees. Remember, your unit circle, all of the radii are 1, but since this is going down, this is actually going to be -1. So at 270 degrees, your point is actually going to be at 0, -1. So that's 270 degrees is at 0, -1. So your basis for this, you have to know the special right triangles, 30, 45, 30, 60, 90, and 45, 45 right triangles, and where they go in there, because we use them as reference angles to find other angles around the unit circle.